Hi, I'm Taeyong Bao. I'm from KIST, Korea Institute Science and Technology. Today, I'm going to introduce about 3D real-time acoustic simulation for transcranial focused ultrasound using GAN model. As you already know, transcranial focused ultrasound is one of the brain stimulation technique to induce the biological effect on the brain. Using the transcranial focused ultrasound, we can do the thermal ablation, BBB opening, and the neuromodulation. However, the presence of skull is one of the biggest obstacles to brain stimulation because of the large mismatch of the acoustic properties between the water and skull. The strong aberration of ultrasound is always occurred. Thus, the acoustic simulation should be performed before the ultrasonic treatment. First, we make the 3D medical model using the CT and MRI and select a target to stimulate and set the boundaries and sonication condition like this. Using this information, the numerical solver gives the acoustic simulation result like this. However, this process takes very long time, so it is hard to implement online treatment planning. Thus, the objective of this work is to make a neural network for real-time acoustic simulation. We aim to reduce the computational time to less than 0.5 seconds. Let's see the more specific this part. To make the training data, we use the conventional acoustic simulation model. The acoustic simulation results were obtained at 600 different transducer positions, looks like this. For numerical simulation, we used the K-Wave MATLAB toolbox. And this is the simulation detail of what we used. We used the 200 kHz single element transducer, and the CT house field unit was converted to the acoustic properties of skull using this equation. And this is the base structure of our neural network, and this network called as generative adversarial network, short for GAN, in which two neural network, one is generator and second one is the discriminator, compete with each other to become more accurate prediction. This video shows the GAN model estimation depending on the training apple. Very first stage, the GAN model gives the very weird pressure distribution result. However, the training goes on. The neural network gives the reliable acoustic pressure distribution result. This figure shows the acoustic pressure distribution depending on the transducer position. Like this figure, GAN model estimates the very accurate acoustic pressure distribution compared to numerical simulation. To see the differences as a specific number, we calculated three physical quantities. First, we calculate the difference of peak intracranial pressure, looks like this. And then we made 3D volume of acoustic focus, looks like this. And we calculated the overlapped volume. Using this, we calculate the dice similarity coefficient. And we also calculate the distance between two acoustic focus. As a result, the peak pressure difference is only 1.5%, and the dice similarity coefficient was 0.8, which means two acoustic focus was overlapped about 80%, and then this distance between two acoustic focus is only 0.7 millimeter. The numerical solution took the 15 seconds to give the acoustic simulation result. However, the GAN model estimation takes only 0.07 seconds. Because of its super fast computing time, like this video, we can know about the acoustic pressure distribution depending on the transducer position as a real time. Linked with the surgical navigation system, we can use this model as online treatment planning. In conclusion, in this study, we made neural network, which is GAN model for real-time acoustic simulation the GAN model estimates peak intracranial pressure within 0.5 percentage error. The computing time of GAN model is only 0.07 seconds. However, it has a limitation. The estimation result limited at the very specific condition. For example, specific subject and specific target, and only it can estimate at the certain sonication parameter. So the model should be retrained for global sonication condition. In this study, all of the acoustic simulation and visualization were implemented on the custom-made 3D slicer extension model using K-wave background. Thank you for your attention.